0.68. These are getting to be pretty challenging examples at the end of this section here. And this is where, not to beat a dead horse, where it will really benefit you to think about your transformations is there's just these 4 types. And don't focus on what you're calling them or what you're doing geometrically. Just focus on the operation, what you're doing to the x and y coordinates. So let's try to talk this one through. There's 3 different transformations going on right here. There's this minus 3. From the f of x, I'm subtracting 3. So this is a vertical shift, which I don't really care about the name. What it means to me is I want to add -3 to the y coordinates. In other words, subtract 3 from the y coordinates, but I like to write it as add -3 because I always remember it's adding when I'm doing vertical shifts. It's just in this case I'm adding a negative number. That's one of my transformations. I got 2 more transformations. This +1 right here is kind of similar to this -3, except now instead of taking away a number from f of x, I'm adding a number to x. So instead of being a vertical shift, this is a horizontal shift. But again, I don't worry about the names other than the fact that it's horizontal. What I'm going to do now is I'm going to subtract +1 from the x coordinates. I'm always subtracting when I'm doing horizontal shifts. I'm subtracting that number from the x coordinate. If that number happens to be negative, I'm subtracting a negative, which you might choose to think of as adding, but I'm always going to write it as subtracting a negative, so I keep these all straight. My last transformation is this 1/2 right here. And again, this 1/2, I'm multiplying the x by, so it's a horizontal transformation. Because I'm multiplying instead of adding or subtracting, it's a horizontal stretch. But rather than focus on the name, what I want to remember is that I'm dividing all of the x coordinates by whatever b is. So in this case, b is 1/2. I'm going to divide the x coordinates by 1/2. And that might seem silly to say divide them by 1/2 when it's a lot easier to just say multiply them by 2. And that's true, but again, I'm going to write it divide them by 1/2. Because then I don't have to memorize what operation I'm using. I just have to go straight from my table. The one other comment I want to make is I have 2 horizontal transformations. When you have multiple horizontal transformations, the order you apply them is very important. You're always going to be, or I am always going to be, I have to be careful here, your book does things a little bit different than me. But if you're using my methods, what you will always do is apply this one before you apply this one. You're always going to shift here before you stretch here when we're talking about horizontal transformations. You're going to do things in the opposite order that you'd expect. You'd expect multiplication to come before addition, but it doesn't. We're going to do addition before multiplication, or in this case, subtraction before division. And I don't even have to worry about numbering this guy because I can do the vertical whenever I want because I only have 1 vertical transformation. So let's apply them to this graph right here. Maybe I'll first apply my horizontal transformations because I have 2 of them. I want to subtract 1 from the x coordinate, and then I want to divide the x coordinate by 1/2. This x coordinate is -2. If I subtract 1 from -2, it goes over here to -3. If I divide -3 by 1/2, dividing by 1/2 is the same as multiplying by 2, so that moves me out here to -6. This x coordinate right here is 0. If I subtract 1 from 0, I'm out here at -1. If I divide -1 by 1/2, it moves out to -2. This x coordinate is 2. If I subtract 1 from 2, I'm down here at 1. If I divide 1 by 1/2, it moves back over to 2. With these 3 points, I have enough that I can sketch a graph like this. This is not my answer. This is an intermediate step. This would be what I'd get just after applying the horizontal transformations. This would be f of 1/2 x plus 1. But that's not what I want. I don't want f of 1/2 x plus 1. I want that thing -3. So to get my final answer, I'll take that thing I drew in green and I will add -3, aka subtract 3, from all of its y coordinates. This y coordinate is 0. If you subtract 3 from 0, you end up down here. This y coordinate is 2. If you subtract 3 from 2, you end up down here at -1. This y coordinate is 0. If you subtract 3 from 0, you end up down here. And my final answer is going to look, that's a horrible drawing. Roughly speaking, I don't know if that's any better, but good enough. Something like that. Did they give me, I guess they didn't give me a new name for it, so I'll just say it's f of 1/2 x plus 1 minus 3. And that's the answer right there. Note that your book does stuff a little bit differently. It prefers to factor stuff out so that you can do the order a little bit differently. I think this way is more challenging. So if you're doing things my way, you'll never factor things out. If you started out with something that looked like this, you take this 1/2 and you distribute it through so that it looked like this. This is how you want it to look using my methods. And using my method, you'll always apply, when you're doing multiple horizontal transformations, the shift before the stretch.